Cool. Okay, let's get started. I understand I'm the last one between, you and the party later tonight, so I'm going to be, careful. And yeah, good evening. My name is Silvano. I work in the Postgres team in Azure. And I've been working on .NET since the very beginning. I would say some of the pre-early beta, when I was not working with Microsoft at the time. So I had quite a long journey learning about the programming languages and the runtime and so on. But recently, around 3-4 years ago, I actually started to see this growth in terms of interest around Postgres. And is constantly, the #1 database in terms of popularity and in terms of developers' adoption. So I thought, okay, that can be a good kind of, career move for me to start working with Postgres as well. And then, pretty much at the same time, we see this kind of growth in terms of adoption of Linux in the server environment. In Azure, the vast majority of virtual machines that are created by customers are actually Linux virtual machines. So I thought, hey, we may have a problem in the sense that, people that have been working a lot on Windows and SQL Server, this kind of technology stack in the past, may need to kind of rethink a little bit about the platform and the technology stack, right? So the goal for this session is answer to this question, right? So how can I reuse the existing knowledge that I have working on .NET when everything else is changing in the platform, right? So in terms of like dev stack, the idea is, hey, I can develop my application on any operating system on my developer, on my dev box. I can still working on Windows. I can work on Linux on the desktop, or I can work on Mac, like I'm doing right now. But still, the moment I'm creating my artifacts, my kind of binaries, and typically today, those binaries are going to be packed in a container for easy of kind of distribution management and so on. The code running within those containers is probably running in a Linux environment, right? And Postgres, which is was born on Linux, actually on Unix, but it actually today works very well on Linux. Can be can follow in my typical kind of client-server application or web app or API app and so on. But I'm also conscious that at some point my code artifacts will be pushed somewhere else. It can be in my GitHub repos, and in GitHub I may leverage things like code spaces for running my builds and stuff there. I can use GitHub Actions to deploy my code somewhere, and that somewhere is probably again another Linux machine, right? And that Linux machine can be in an Azure environment, can be in AWS, GCP, can be in a data center, right? But still, most probably in a Linux VM or in a Linux environment. So my goal here is to show you how across all these different stages and workflows in terms of development, we can actually leverage Linux, .NET, and Postgres together to create our apps. So first of all, .NET since quite some time is running on Linux. You can install it through several ways. There are a bunch of distros that actually have .NET packages as part of their package feeds. There's a Microsoft package repository where additional distros are actually and versions are actually supported. There are snap packages that can be used again to deploy, and there is a lot of support for manual and scripted installations. Some of those feeds, the package feeds, don't support ARM architectures. Or typically, they do have packages for x64 Intel type of processor architectures. So, like in my case, I'm running on a Mac and I'm running on Linux. But it's on ARM CPUs. I need to actually do some scripting, which is actually very simple. I will show you in a second. Once I have .NET deployed in my target, I can actually still use my preferred operating system on the client and connect to my Linux environment from Windows. Of course, we have the great WSL. So you can keep using Windows as a working environment, but we are basically connecting to our VM or our containers running in WSL, thanks to the VS Code remote development extension, which is great, by the way, in this regard. Same for Mac. I mean, Mac is not Linux, right? So you typically don't, if you're targeting Linux, you want to have a real kind of Linux environment. So you can use tools like Parallels and create your Linux VM. Or again, you can connect to a Linux environment through VS Code and remote development extension. Or for the kind of more, the brave that likes to use Linux on the desktop, of course, you can still install all your tools starting from VS Code and all the .NET tools that are needed to basically manage the entire life cycle of your application, from building, debugging, testing locally, running your code, extracting things like, performance metrics, capturing dumps in case you have an issue and so on. You can do that locally. You can do that remotely by SSHing into a VM or by leveraging some of the diagnostic capabilities that, PaaS services like Azure Web Apps, for example, or container apps are providing. Because nowadays, most of the Azure services in a PaaS environment are also running on Linux, right? So if you are deploying on container apps, for example, those are Linux containers. Same for AKS in most cases. There is kind of native support, some kind of support for Windows containers as well, but in 99% of the cases, those pods and so on will run on Linux. Okay, so let's take a look at the installation part, right? So I'm gonna move here to my box. So typically, as I was saying, if you are on like an ARM64 architecture, what you do to, the simplest way to actually have a .NET up and running is to download the .NET install script, which is a great tool. It's a bash script that basically you just make it executable, and then you can just decide which channel, meaning which kind of family of SDKs and runtimes, and which architecture you want to install .NET on your own machine. And the .NET install tool is doing all, everything for you, except at the end, you just need to set up basically a environment variable, so .NET root to whatever you are basically extracting your .NET bits, and everything will start working just normally as you would do it in a traditional Windows VM. The other way that you can do is actually to deploy your binaries directly, your packages from the various kind of areas in the Microsoft portal, download areas. And once you have downloaded, you just basically unzip your package into a local folder, right? And that's it. By just copying the bits and running, there's no other kind of installation mechanism required. Right, so this is again when you need to support a platform that may not have package feeds compatible with your processor architecture. If you instead are running on like Ubuntu, Debian, some of the major Linux distros, you can actually leverage their own package management mechanisms. Yeah, you just need to basically attach to some of the feeds, the Microsoft distribution or package feed, and then you can use apt-get install and update. You can do you can use DNF, and you can use all the canonical kind of package management thing, right? And once you have .NET installed, basically it will look like your .NET on Windows, where essentially you have, again, your SDK, multiple SDKs, you have your kind of runtime environment, all your workloads that can be installed, and so on and so forth, right? So this is regular, kind of regular .NET. You can see I have Visual Studio Code here. You can install the C# Dev Kit. You can install pretty much all the tools, all the extensions, and whatever you think it makes sense, right? But sometimes you need to actually do some low-level debugger, right? So in .NET you have a bunch of great tools. .NET tool list. That you can install even on Linux, and between these tools, as I was saying, there is .NET Debugger extensions. The .NET Debugger extensions is installing all the low-level infrastructure, so-called SOS infrastructure, that you can use to actually debug your code. Right. So I have the smallest possible .NET app here. This is kind of trademarked by Steve Gordon, who's presenting this usually at the NDC conferences. So this is a .NET app, right, with nothing in it. It's just open the curly brackets and close the curly brackets, right? And we can compile this. We can compile this using CSC, the .NET compiler. I actually have the command line here. By the way, everything here you will find under my own GitHub repo. So it's scoriani / Azure Dev Summit 2025. So if you are interested, you can go there, right? But again, let's say at this point we have our .NET DLL, right? So the .NET DLL, we can see that it's a .NET DLL because sorry, I need to do the right folder. Okay, because this is not a Linux executable. This is a portable executable. So it's a format which is typically used in Windows, right? So in order to execute this, we need the .NET runtime to do that. But we can actually explore whatever is in there. And again, there is another .NET tool called MDV, sorry, metadata viewer, where if we do this and we point this to our assemblies, yes, if I can write, we can explore our .NET assemblies and get pretty much everything, right? So here we can see that this is a .NET file, of course. It's a module called main.dll. There are a bunch of references to other types, like the infrastructure types, the object, of course, and so on. And this is basically what is helping us to go through the low level of our .NET code in case we need to do some low level debugging here. Like, for example, we have, I don't know, memory leaks or other problems. And you can see at the bottom here, there's also the IL disassembly, where this is the main method that was not there in my code, but the compiler is basically creating this for me using the using the high-level kind of method definition that we have now in .NET. And this is doing 0, right? It's just returning. This is executable code, actually. And of course, there is the constructor of the system object. You can see these numbers here are basically metadata references that we have seen previously in the .NET tables. So if we do this, we can actually execute our code, and it's doing nothing, right? We know that it's working because I think this is the command. Because this is the basically return value for the execution of my program, and if it's 0, it means it returned correctly. Otherwise, we would have like -1, an error code here, right? So if the code is executing here, it means that we can debug it, right? And in Linux, especially in ARM processors, it's the common debugger that we have is called LLDB, right? So LLDB is a command line debugger that we can use, and we can debug our .NET execution here, .NET, and main.dll, which is our code, right? So you notice here that there are some specific extensions that are specific to .NET, because now we have a bunch of commands in order to troubleshoot and debug our .NET code in Linux or in any other environment. On Windows, you may have heard about WinDBG, which is the equivalent low-level debugger. But here we can actually run our code, and as you can see, the code process is running, and it's just exited with status 0. We can actually load the symbols. And these symbols are helpful for us to start debugging our code, right? So we can use breakpoints. And if we know some of the .NET kind of internals, we know that there's a method called execute main method that will be invoked the moment our runtime, basically the runtime is loading our managed code, right? So we are creating a breakpoint here, and now we can, run our code, and the breakpoint is actually hitting, right? So this is, as I was saying, low-level code. This is the runtime itself that we are debugging, but we can also place breakpoint on our managed code, right? So we can say bpmd, which is a command of these extensions, debugger extensions for .NET, and we can say, okay, this is main.dll, our method, our module, and our method is called, as we saw previously, brackets main and $. Right now, if we continue in the execution, we can see that we are actually stopping at the main method of our code, right? And this is actually the JITed code, so the machine code for our ARM processor, which is different from our Intel processors and so on. And the interesting thing here is that we can start using these commands, name to EE, and navigate through the metadata of our .NET code, right? So in this case, I'm asking, hey, where is the method definition, method description for my main method here? And like in this case, I want, for example, to dump my IL code for this particular method, right? And this is effectively the IL code that we saw previously in our disassembled application. So what we can do here, we can do things like dump, for example, heap, right? And look at the memory, which is used by our application, right? So we can see that we have a bunch of objects here in the heap. We have a bunch of strings, right? Strings are typically loaded up by the runtime to set things like, environmental variable in the process and so on. So we can do, like, take a look at this single object and do dump obj dash empty method table and it's dump md. Where is this? I don't remember out of my mind the command, but basically we can take a look at each of these 47 strings and maybe, again, as I said, we may have a memory leak or something that is growing over time. So with this method we can debug everything on our .NET code. In addition to this, as I was saying, we do have a bunch of other native tools that are giving us the ability to interact with Entity Framework, as an example, right? So doing all our database management, create our migrations, set up our database, and so on. We do have tools for taking dumps, for reading performance counters. So all these tools are available as .NET tools or as native binaries for every process architecture and system, operating system, so that if you are debugging or troubleshooting a production application and this is running on a Linux box in the cloud or anywhere, you can SSH in, download one of these tools and do whatever you would do on your local machine or on a Windows machine anywhere. Okay, so as I was saying, today when we are creating an app, we are probably containerizing it, and for good reasons, because that will give us the ability to pack our own code with all the surrounding libraries and environments that are needed, making sure that if it's running on my machine, it will run also anywhere else, right? So the packaging an app using, again, Docker, using Podman and such is a great way for doing this. And for .NET code, there are a lot of existing images that we can use as base images for building up our own applications, right? There are Linux images for the SDKs, for the runtimes. So if you need to build your app or just running your app, and these images are supporting all the major distributions, Debian, Ubuntu, Alpine, Azure Linux, because Microsoft, since quite some time, is actually deploying its own and developing its own Linux distro, right? And I think I have it here somewhere. Let me. Yeah, so I have my own container here, which is actually running on Azure Linux 3.0. You can download the ISO and create your own virtual machine on your local machine. You can most probably meet Microsoft Azure Linux every time you are deploying a Azure Kubernetes cluster, or if you need again to create your containers for Azure container instances and so on. So the interesting thing is that those Linux images are typically more compacted compared to others, right? We will see later on, the size is probably half of the of some of the others, and also in terms of maintainability. So there's a strict kind of security review, and the package management is actually crafted in order to make security and vulnerability reduced at the very minimum, right? So of course, it's one of the other Linux distributions that you can think about the moment you're packaging your apps. How we create .NET containers? There are two ways. One is using Docker tools or Podman tools and so on, and defining your Docker file. and so the instructions for the container environment to build your images, or now you can use the .NET SDKs, right? So there's a new way of publishing .NET code, and with the switch -t publish container, you can create containers directly from your .NET creation workflow, right? And those what is interesting here is that, let me go back to my code here. So this is a super simple app. Actually, let me open the folder. So this is a very simple app which is invoking 3 methods and is writing down what operating system, what processor architecture, and what framework description my application is running on. So if I execute this, is telling me that right now I'm running on my Debian machine, I'm on ARM64, and I'm using .NET 9.09. Okay, so I have a Docker file in this folder where I'm basically just declaring what I want to, what I want the Docker tools to do in order to build my image, right? So here, what I'm doing, I'm just using a particular image for building my app, right, and configuring where it's gonna, build, and after, at the end of the build phase, I'm basically just recompiling for production, and basically I'm finalizing declaring the entry point. Which is basically invoking the .NET tool and launching my my application. So here I can do Docker, yeah, build. It's, if I can write, I'm going to do give it a name, my Dev Summit. Okay, and I'm going to use the dot to say build, the Docker file, build using the Docker file on this folder, and because this is the name of the image that I'm going to create, right? So as simple as that, the Docker tool is basically creating my app, and now if I'm listing my Docker images, I have my container here, right? And this container, I can execute it, Docker run, my Dev Summit. And again, this is just running on the same exact environment here. Of course, I could have used a different base image with a different Linux distribution and configuration, right? But the principle is I can use the Docker tools for that. Now, what we can do now in .NET, as I was saying, is to use .NET Publish and targeting the publishing a container. And in our project definition, we can actually specify what is the our image name, what is the container-based image, and in this case, what I'm pointing at is, hey, I'm going to use Azure Linux instead as a base for my container. So I can say here .NET, not Docker, but .NET publish, and I'm going to do the switch T publish container. Right, and what? Now this is every time it's creating a new file. Okay, so now what it's doing here, it's publishing a new container here, and if I'm, it's probably downloading. Yeah, and now if I'm doing Docker run. my custom app, I think custom app is called. Okay, we can see that now the Linux distribution that we are using is not Debian anymore, but is actually Microsoft Azure Linux, right? So again, there's there are a number of switches here in the project definition where basically you can define, again, what kind of container family you're using. You can create like ahead of the time compilation, so you can shrink things. Just to give you an example, so the Docker images. So the images that we created previously is 228 megabytes. The one with Azure Linux is 109. Right, so we know how important it is to create kind of smaller containers because you know, the time to pull images will be reduced, the amount of storage space used will be reduced, and typically when we do things like Azure Functions or even in Azure Web Apps, the startup time will be much faster. So you know, this is you know, using the right type of base image is very important for performance, but also for security and for manageability reasons, right? So you know, we need to kind of consider that as well. And again, there are a number of different images depending on the operating system, the version, the processor architecture, the image type. So if we are publishing an ASP.NET app or like just a worker process and so on, there are different image types. There are also a family of images called chiseled, which is basically stripping out everything which is not really needed within our kind of Linux distribution, right? So basically, the image is so small that it can only run your code and nothing else. So, you know, the bash shell and so on, those are stripped away. So it's very minimal kind of size in terms of even in terms of attacking surface from a security perspective. That's why it's super important. Okay, and I showed you already some of this. So, but when our code is running in a Linux box, which is remote, or in a PaaS service hosting our code, how can we monitor and manage that, right? So our application, of course, is made of our application code, the runtime components like ASP.NET libraries, the .NET runtime, and so on. And there are multiple ways to keep monitoring and managing our remote applications. Right. Of course, you know, there's the console logs that typically the environment running this code is capturing. So we can connect to that environment and trace our logs. We could also debug it remotely using Visual Studio or Visual Studio Code. They are supporting remote debugger. But the moment we are doing remote debugger, the application is stopping, right? So no one else can actually use it. That's why there are typically less intrusive tools like the ones that I was mentioning previously, .NET counters, .NET trace, .NET dump, that can be used to take a snapshot in time of your running app. And with that file, you can use the same tool like LLDB that I was using previously, or you can use Visual Studio. You can drag those files from your Linux box to a Windows box, load it in Visual Studio, and Visual Studio will give you all the rich kind of and graphical information regarding the running of your application. You can also like monitor the application remotely. .NET Monitor is a great tool. Is a local tool, but is also available as a sidecar container that we can deploy on Kubernetes, Azure Container Apps, Azure container instances, and so on. And it's basically connecting to your app using Unix sockets, right? And it's sucking all the metrics and the other informations And then you can do all the diagnostic remotely. So you can invoke like triggering a process dump. And then you can basically receive back the file, and then you can do all your debugging and troubleshooting there, right? So you can also connect it to other monitoring systems like Prometheus. Then you can print, plot your metrics on Grafana and all these other kind of OSS tools, right? But .NET Monitor is basically giving you a glimpse of what are the .NET processes running in your containers, managing dumps, managing traces, so all the events that the runtime and your application code are generating, live metrics, and so on and so forth. So we have essentially the full kind of diagnostic environment. And in Azure specifically, there are a bunch of services that today are hosting Linux container natively. So Azure Kubernetes services, Azure App Service, container apps, VMs, of course, because you can still deploy code on VMs, Service Fabric. So those are all the hosting different services, but you can do exactly the same on AWS or GCP and still keep using these tools in order to manage your .NET code remotely. Okay, let's come to the database side of the house, right? Why Postgres? I mean, again, Postgres is getting a lot of traction within the developer communities because it's community-driven, it's open source by nature, it's portable across Windows, Linux, and other operating systems. It's designed actually in Unix and Linux. It's a little different than SQL Server or other databases that you may be more familiar with, but it has this concept of extensibility. So there's basically a community creating extensions of the database that the more popular ones are getting used and famous and actually improved over time. So they are covering areas like, I don't know, time series databases, or column store indexes, like GIS, so geospatial information, and so on. So this extensibility is actually pretty, pretty leveraged in the community. So we can deploy Postgres as a local service in our VM or in our server, but we typically containerize it, and we can run it also in Kubernetes. There are a lot of Kubernetes operators that are making very simple to create like your master and slave replication mechanism for high availability on a Kubernetes cluster. There are some differences compared to other databases like SQL Server. One example is how it manages concurrency. In SQL Server, we know for years the concept of locking and pessimistic and optimistic locking. In Postgres, there's only optimistic locking, actually. There's a multi-version, multi-rows. Basically, every time we are modifying a role, a new row is created, and the old one is basically tombstoned. And there's a back-end process called vacuum, which is basically taking care of eliminating those rows. Why is important? Because the moment we are writing applications that are interacting with the database, we need to think in terms of optimistic concurrency. And there are ways to use tools like Entity Framework or ADO.NET data provider for Postgres that are managing these differences for us. So in our case, we are actually programming in Postgres like we were programming in SQL Server from a data access perspective. From a tooling perspective, there are all sorts of tools, command line tools, from a monitoring and management perspective, from a programming perspective, but we can actually use our new extension. So this is something that Microsoft has created recently. So it's similar, again, to the SQL Server extension. We can connect to Azure instances, we can connect to containers, we can connect to local installations, and we can take a look at things like, I don't know, schema, for example. So we can visualize our schemas, we can execute commands, we can debug, and so on and so forth. It's a pretty handy extension, and but again, depending on where you are coming from, you may be more comfortable with tools like pgadmin or dbeaver, and so on and so forth. Postgres supports more complex programmability concepts compared to other databases. Like there is a table inheritance, right? Like we do with classes in .NET, you can basically inherit a base table in a different table, and then you can basically only add those specialization columns in your derived table, and this is for managing kind of complex applications can be super helpful. Right, but where it's super easy is around like pattern matching. It does support regex from the beginning. It does support ILike, which is a more powerful way of doing text search and so on. And also JSON. In JSON, there's full support from an indexing perspective, from an application programmability perspective, and so on. There's also a way to connect back to like SQL Server or Oracle, like the good old linked servers in SQL. So you can connect to Postgres and then query tables that are in a different database or doing merging and so on. As I was saying, especially from a development perspective, using Postgres and our .NET container is super easy. Right, so there are all sorts of existing official images for all kind of hardware architectures, and typically the distributions used are Debian and Alpine. Or you can build your own, because we have source code for Postgres, and it's not super complex to actually create our own customized images. So how do we access our Postgres data from .NET? As I was saying, there's an official ADO.NET provider called Npgsql. It's compatible, with ADO.NET. So it means that it behaves, it looks and behaves exactly like the other providers. Okay, and on top of that, there's an entity framework core provider, which is already aware of all the specific Postgres features and capabilities. So all the conventions are working as expected in Postgres in terms of naming conventions, querying conventions, and so on. With Npgsql and the entity framework, we can actually manage the whole data lifecycle in our application. So from creating a database, creating the schema, updating the schema, doing additional migrations, seeding our databases with the data. So you don't necessarily need to connect to the database, do all the DBA preparation and so on. You can just use it as a local database for your applications, and this is completely possible using tools like Entity Framework or like community tools like, for example, DBUp, which is an interesting .NET library to manage, again, the life cycle of your applications. If you don't want to manage your own databases, we do have a managed service in Azure, which is called Azure Database for Postgres Flexible Server. It's based on vanilla open source Postgres engine, right, which is deployed in a Linux container, in a VM, in Azure, and it's managed in terms of storage, backups, high availability, best practices from a configuration perspective, and so on. So basically, you just deploy an instance, and you can start interacting with your applications, and you don't have to think about managing, the database at the low level. Okay, so let's take a look at some code here. I should have. Okay, so I'm using a database that I have in my local dev box here. if I can connect. So this is the sales database. Those of you who remember the good old Northwind database in SQL Server, this is basically a porting on Postgres, right? And what I did here was leveraging entity framework. As I was saying, if I look at the project here, I'm using the entity framework core package for Postgres within Npgsql. By the way, Npgsql package is created and maintained by our own .NET team, so some of the members, but it's open source like the rest of .NET. So there's great contributions also from the community there. And so I created this DB context with all the mapping the various tables with some of the details and such, and then I have my own model here with all the classes, and for each class, of course, I'm declaring what is the primary key, what are the column names, and so on. So exactly what I'm doing with SQL Server or with other databases. And then I'm executing this, and you will see with a little bit of help from Copilot, actually. He created the front end for me because I'm not really a visual type of programmer here. But this is a pseudo sales management system where I can see my customers, right, where I can see my products. And when I'm clicking here, if I go back, we can see all the Postgres queries that have been created by entity framework for me. Right? So we can trace, we can optimize our queries and so on. And we can also create a new order. Here we have cached all the like customer names, and so we can say, okay, this is order for today, this product, and I want 4. And then I'm basically creating my order, and this is my order. And if I go back, we should see also the insert commands somewhere. Yeah, the insert commands using parameters and all the best practices in terms of data access. So we saw how to run .NET on Linux, how to containerize our app, how to connect those apps with Postgres, right? It's pretty easy and pretty familiar, actually. We are not really revolutionizing what we are doing. It's pretty much the same kind of tool set and the same practices that we were doing on SQL and Windows. So now I have my components. I want to basically manage the entire life cycle of my database. So I want to deploy it, develop and debug it locally without thinking in terms of containers and all the low-level details. I would love to have a way to actually manage all this complexity for me. And this is where .NET Aspire is coming from, right? So it's very kind of opinionated in the sense that, the Aspire team took some decisions to simplify this entire life cycle, but still exposing all the details for us in terms of tracing, debugging, and managing our applications. Right. So what I did here was let me pick this guy here. Okay, so it's a simple application here. My app is really this web API where, let me show some code. This is a regular web API. I should have, here is my controller, where I'm just returning the list of customers that we just saw in the database, right? Super simple from an application perspective. And then there are some kind of infrastructure stuff like, for example, I'm defining my DB context, which is here. super simple DB context, only one DB set for my customer table. And then I have, of course, my model here, which is a simple customer class with ID and name. So simplified to the bare minimum for demonstration purposes here. So as you can see here, I don't even have connection strings. How can I connect to my database? How can I wire all these variables together in order to have my application up and running? Basically, in order to do that, I just added an Aspire application host. And what Aspire is doing here, what I'm doing in Aspire, is effectively defining my own distributed app. Right? My distributed app is my way to tell Aspire what are the steps in order to create, instantiate, configure, and run my application locally, but even remotely in a cloud environment or in a data center if I like. So let's take a look here what I'm doing. So basically here I'm just trying to understand if I'm actually publishing my app to my target environment or if I'm just debugging. So if I'm debugging, what I'm doing here is, okay, add a local Postgres database and including also the pgadmin environment for me to execute queries on the database, do some management, and so on. So I'm defining all my resources. In this case, my database and my web API. Right? And the web API is just the project that we saw previously. So what Aspire is doing is wiring up those components, right? And it's making, finding its way to actually publish it for now as a local development environment. So I'm actually creating references. I'm saying, hey, publish my web API only when you have done my database work and wait for my Postgres database to be up and running before executing my web API call. So this is the local environment. If I'm actually publishing this to the target environment, in that case, I'm just creating an Azure Postgres flexible server. So I want to deploy a managed service in Azure. And then I want actually to deploy my web API in Azure. And by default, Aspire is doing it using container apps. And I'm also saying, hey, please publish my external endpoint so I can be reachable through the internet and so on. So at this point, I can, as I was saying, do .NET run and picking up my project. So I need to point to the Aspire project that I'm running right now. So this is the C# project. And when I'm running my .NET app, basically is executing the Aspire code, and the Aspire code is deploying my application components. So what I have here is, when this will run, I have a nice dashboard that I can click. And the dashboard right now is basically showing me all my application resources, right? So there is my Postgres database, my web API, my database within my Postgres, and I have my admin for the database. So when I'm, let me zoom this a little bit. So let me, for example, connect with my pgadmin, which is the UI for managing my database. So this is a standard open source tool where I can connect to my running database in a container, and I can take a look at, hey, what are my schemas? What are my tables within the schema? So because I'm still developing here, right? So I want to have control on everything. So I want to see my data, I want to play with my data and so on. But at the same time, I can also take a look at what's going on from a logs perspective. So I have structured logging, and I can see, for example, that my web API here was doing some activities, including like connecting with the database. For some reasons, the first command here was failing because it was trying to do a migration, but the database was already at the latest version. So this is the message that is returning. But again, it's basically, I can trace whatever is happening in my distributed app over there. Right? And I can, of course, connect to my web API. And if I go to that customer, if I can, customer. Okay, see, those are the two rows that I had in my database. So the app is running locally, right? So now that I've tested and I've been running on my application locally. Oh, by the way, I didn't show you, but let me recreate this app again. What this is doing is basically using Docker locally to create like my Postgres, all the components that are needed in order to execute my application. Okay, once I'm done, what I can actually do is I can use another tool available on any platform, which is called AZD, Azure Developer CLI. And AZD is actually aware of Aspire, and it can generate all the Azure infrastructure needed in order to run my application by using a single command, which is called AZD app. Right, so with AZD app, now typically creating resources in Azure takes minutes, so I already created. But what AZD app is doing is basically looking at my Aspire infrastructure, looking at what are my services that I want. I just configured what is the location and my Azure subscription where to deploy my services. And so it's doing this for me in Azure using Azure services like Postgres and container apps, as I was saying. So if I can only remember, so if I do AZD, I think it's show. So is showing me the existing application that I created a few minutes ago. And I can now navigate. This is my public endpoint for my app. And if I do -customer, now we are running in the cloud on an Azure container app with my .NET application code, talking to the Azure Postgres database running in the cloud as well. Right? So all this by just configuring my Aspire application host and telling him what to do. So this is a very, very simple example. In reality, there's a great demo app which is called eShop. I don't know if you are aware. It's available in GitHub under github/.net. And this is a much, much more complex application. I'm just giving you a quick glimpse. Project. I'm in the wrong project. Source. I need to find the application host here. Okay, and now my project file. Okay, so this app here is full kind of e-commerce project with order management, warehouse management. It provides a public website, a mobile app, and such. And if I show you, so as you can see, it's a much more complex project. It's all based on Postgres as a database, and again, you can, we can take a look at our web app here. So you can do the classic kind of, ordering, checkout, and so on, and it's fully functioning actually. And then you can take this and do AZD up and get it published in Azure with tens of different containers, your Azure database for Postgres, and so on and so forth. So if you want a serious app to study and to understand how you can use Aspire in your own environment, this is definitely the one for you. So just to recap, as we are out of time, we saw how we can install .NET on Linux, manage our .NET applications there, debugging, diagnostic, do the diagnostics, and so on. And then how we can publish our .NET code, our Postgres code, and everything else in our application in native services in Azure. But you can do the same in AWS or on your Kubernetes clusters using Aspire. Okay, I hope you like this. This is the link where you can find the eShop app. And at the very beginning, let me. This is the link for the demos that you saw today during the presentation. So thanks a lot for your time. I hope you will have a great party tonight. And if you have questions, I'm always available here or at the party later on. Thanks.